Hello, Mr. Schoening here, and today I'd like to show you how you're going to do the apparent weight to determine density lab. In Google Classroom, the assignment looks much like this. If we open it up, we see it is opening slow, but it is there. We're going to have to use Pivot Interactives to do this again today. So if we look for this Pivot Interactive, it's telling us that there's going to be a digital balance in the video, and it's going to be used to read the weight of the object. All right, so first step in the procedure is they want you to use a net force statement to determine the equation. So really, technically, you should do this twice. You should do a net force statement for when the object is on the balance, or just, I'm sorry, suspended in the air, and when it is actually submerged in the fluid, and try to use your information regarding that. Now, just so you can see what the activity is. What you see here is that there is a balance, digital balance, and this right here is going to be attached. And when we add to this, it will record the mass. So, or it'll record that mass. So if we hit the play button right now, I'm looking at metal 1. We can see that they hung it on here, and it's reading a value. Originally, remember when there was nothing on here, it was reading 0. So it's actually tared right now, and when it's hanging, we do have a value. Just there we go. That number obviously will be very important, because if you think about it, we can actually do our force diagram for this when it's just hanging here, keeping in mind that tension is technically what the scale is providing here. So we will be able to use those numbers to try to figure out, a couple things about it. Please also keep in mind that these are grams, so that's 31.15 grams. You must turn this to kilograms as we're doing this today. If you want to use the density values like we do with kilograms per cubic meter. So please be aware of that. If not, you're going to have to convert some stuff. I'd try to avoid that if we can. All right, if we play the video the rest of the way, we will see the person lowers it. We can see the scale is bouncing around. And okay, it will hold still right about here, and we see that there is now a new apparent weight going on here. Not apparent, well, actually, sorry, technically apparent mass. Now, to turn that to an apparent weight, we do have to remember that that mass needs to be multiplied by 9.8. The same thing, by the way, when I was hanging up here too, but we want to keep that in mind. So this is not actually the weight. This is actually the, like we said, the apparent weight. That's what it's reading after the buoyant force kind of kicks in. So you'll need to use your force diagram in its current state, using again, the tension is going to serve as the force holding it up, and that's what the scale is actually reading. So with that, that's basically what you will do. Now, this problem is very similar to the last one we did on the buoyant force worksheet in terms of what you're trying to accomplish. But ultimately, what we are trying to do is use those equations to determine the density of the material that is right here. And then what we will do is when we go back to our worksheet and we scroll down, we see that we have a list here. By the way, it does expand down to the next table. When we do find the density using the approach that we're trying here, we're going to identify which one's which. So I'm going to ask you to do this all 5 times, or for all 5 samples. But here, I only need you to show me the calculation that you did for the 1 sample. I will trust that you did the same thing for all the other 5 to get your number here. So basically this here says use the table to record all your constant values. You can add more boxes if you needed to. Actually, this table is slightly off. This was meant to be a data table, but you can just literally type it here. So for example, one of the things you would need is gravity. So if I write down gravity, I could just mark down that's 9.8 meters per second squared. Just write it that way. And instead of doing boxes, you can just write them in this line here. My original thought was to put them as boxes. So all the measurements that you will develop in your equation here, you'll want to list here, and including the ones that you measured from the video. And that's basically it. So basically, you're just going to do this lab. You're going to try to figure out the densities. You'll record them in here. When you're done, you'll hit submit, and that will be the lab. If you have any questions, please feel free to use my office hours to discuss anything with me, or if we have some time in class, we can certainly go over then. Until we meet again, have a great day.